Welcome to Substitution Part 3. There's probably going to be a Part 4. All right, so let's get started. What will my u be? Try and maybe think in your head what u is going to be before I write it down. So u is going to be x to the 1/2 or square root of x. Because I see du there. Du is equal to the 1/2 moves in front. Excuse me, du dx. So it would be 1/2 x to the negative 1/2. And I see x to the negative 1/2. I just don't see a 1/2. So 2 du equals x to the negative 1/2 dx. So the u is going to replace the square root of x, and the 2du is going to replace the square root of x in the denominator and the dx. Right? So this is just going to be 2 times the integral of cosine u du. Super simple. Now to integrate, we've got 2 sine u plus c, and let's just replace that u with f of x equals sine, and that's the square root of x plus c. And we have enough room to do a check here. Let's check it. F prime of x, by differentiating, f prime of x is equal to, I got to take the derivative of sine blop is cosine blop, and the derivative of blop, this is x to the 1/2, so that's going to be, oops, I almost forgot to write my 2. Sorry, f of x is equal to 2 sine square root of x. So when we take the derivative of that, f prime of x is going to be 2 cosine blop, and the derivative of blop is times 1/2 x to the negative 1/2 power. Derivative of the c would be 0 because it's just a constant term. The 2 and the 1/2 cancel, and so if we simplify this, this is f prime of x equals cosine square root of x divided by square root of x, which is exactly what we see above. Right? That's simple. This is a creative use of substitution to deal with problem number 1, which is the fact that we have 2 terms in the denominator. So we're using a substitution to make it 1 term. So we're going to let u stand for those 2 terms. This works when you've got nothing but x's, and those x's are raised to the first power. It would also work if this was 3x squared, because then I'd have its derivative sitting up. No, it wouldn't work, because the derivative, yeah, it would work, because the derivative would have gone up to the numerator. So if I had 3x squared, the derivative of that would be 2x, and I'd still be okay. We'd just be using substitution in a very different way, the way I've been showing you. This is just a creative use because I've got x's, but I have 2 terms in the denominator. And the problem is you can't have a quotient with 2 terms in the denominator and be able to integrate it. So we're going to change those 2 terms to 1 using substitution. So u is equal to 3x minus 7. However, that leads to problem number 2. Let me show you what problem number 2 is. 2x over u dx. And problem number 2 is I've got x's and u's all mixed together, and that's no good. So we got to figure out how to replace the x in terms of u. So we're going to rewrite x in terms of u, and I can do that using u equals 3x minus 7. Well, if u is 3x minus 7, then u plus 7 is 3x. And u plus 7 divided by 3 is x. And if I multiply that by 2, I've got 2x. So we're going to replace, I'm going to pull out the 3 there. We're going to replace that x in the numerator there with a u plus 7. All right, so now we can integrate. So, well, we can almost integrate. We got to do one more thing, but let me just rewrite this. So we've got the 2/3, and I have the u plus 7 in the numerator. I've got a u in the denominator. I need a du. So we integrate, we differentiate the u equals 3x minus 7, du dx equals 3. All right, so the reason this is no problem is because the derivative of x to the first power is just going to be a constant. And we can solve for that. We can move the constant to the other side. You can't do that with a variable, but you can with a constant. So it's just a coefficient. It's no problem. So I couldn't add or subtract anything, but I can divide. I can divide by constant terms. They're just coefficients. So 1/3 du is equal to dx. We're just going to replace that du with a 1/3 and a du. And on the next page, I'm going to integrate. Okay? So now I've only got one term in the denominator, which means I could simplify this into just the sum and difference of some terms. And we can definitely integrate those. That's just going to be the power rule. Or other rules that we know. So first of all, I'm going to combine that. That's 2/9. And I'm going to divide. So u divided by u is just 1, so that's just du. I'm going to put parentheses here so I don't have to write the 2/9 twice. And then plus 7 divided by u. It's just going to be 7 over u du. That we can integrate. So 2/9 integrating u is du is just going to be a u. 7 over u, that's 7 times the natural log of u, and that's all plus c. And now I'm just going to replace f of x equals, and I'll distribute the 2/9. 2/9 3x minus 7 plus 14/9 natural log of 3x minus 7, all plus c. Okay, and we're done. And notice I have the absolute value bars because 3x minus 7 can be negative, but natural log cannot. All right, and I'm not going to bother even distribute the 2/9. It's fine the way it is, and we're done. It's that simple. So if I differentiate that and clean it up a bit, simplify it, and reduce things, I'll get the function that we started with on the other page. And maybe if you have questions on this in class and you want me to do that, I will. But I won't do that on this tape right now. I'm just going to continue on. This is one I'm only going to do part way. I think it might be a homework problem because I show it in your notes. It's only being done part way. If it's not a homework problem, then I'll do it the rest of the way. But in my notes, it says the rest is for you. So that I think it's a homework problem. If you've got something like e with a function with a exponent that's a function, it's a good idea to make that your u. And actually, on your notes, I did this as 2 substitutions. I actually did it more complicated. I'm going to do it a little bit more simply here because I just realized that I could do it just a little bit simpler. The result is the same, but I think this will be easier for you to follow. All right, so in the notes, I made the u tangent x, which is okay. I just realized, though, that I can actually make it tangent squared x. I've got the derivative for that, the whole thing, so that I don't have to have a u squared and then do it again. All right, so the derivative du dx equals, I've got blop squared, so that's 2 blop. There's the tangent part. And then I got to take the derivative of blop. Derivative of tangent x is secant squared x. I don't know why I didn't see that and why I did it more complicated in the notes. The only thing that's not there is the 2. So 1/2 du equals tangent x secant squared x dx. And the rest is for you. I'll just set this up. So 1/2, and now I've got 1 over e to the u du. Right? And you get to do the rest. On to the next one. All right, using some trig identities. I have 1 over cosine squared x dx. This is not a substitution. Okay? I don't see a sine x. If I took the derivative of cosine squared x, it would be 2 blop times the derivative of blop. So I'd have 2 cosine x sine x. And I don't see that. However, I could make this more simple because cosine squared, 1 over cosine squared x is just secant squared x. And that is super easy to integrate. No substitutions needed. it's tangent x plus c, and that's it. We're done. Okay? Simple. So sometimes you need to simplify it, rewrite it first. Right? And it's not a substitution. So I wanted to show you sometimes what looks like it could be a substitution is not. This one is a substitution. Excuse me, this one is not a substitution, but it is a rewrite. Again, it's a trig identity. Okay? I looked at it just a little bit too quickly. This one is super easy. We've got cotangent squared 3x dx. I can replace that with something that I can integrate because cotangent squared 3x is not going to be it. It would have to be, it'd have to be a chain rule, right? Because if I made the u cotangent 3x, then I'd have a 2 blop. So I'd have a 2 cotangent 3x, and then I'd have the derivative of cotangent 3x, and I don't have that. However, I can rewrite that as cosecant squared x minus 1. So I have cosecant squared x dx minus 1, or dx, and that we can certainly integrate. Right? So your secant squared x, while we can't integrate other functions squared without the derivative, it would require a chain rule. Not so for secant squared x and secant squared x and cosecant squared x, because just like the derivative of secant squared x was tangent x, the derivative, just like the integral of secant squared x was tangent squared x, the integral of cosecant squared x is cotangent x with a negative. So this is negative cotangent x minus integrate dx, that's x, and I meant to put an f of x there. Let me just move everybody over just a tad. F of x equals, now my negative is getting lost. Move that over just a little bit, and now I can add, oops, plus c. And we're done. That's it. Okay? So no substitution on this one either. All right? So sometimes it's not a substitution. It's just simplifying first. Anytime you have sine or cosine to an odd power, pluck off one, rewrite the rest with the Pythagorean identity, and use a substitution to integrate. So sine squared x plus cosine squared x is 1. That means that cosine squared x can equal 1 minus sine squared x. And that does apply even when you don't have it to just a square. Right? As long as it's even. I can replace an even power with 1 minus sine whatever the even power x is. Right? So long as it's even. Can't do that for odds, just evens. So I'm going to pluck off 1. I've got cosine x. And then the rest of this is cosine 8x dx. I'm going to replace that. Cosine x times 1 minus sine 8x dx. All right, so now we can simplify that. I'm going to make that, and I'm going to rewrite this as 2 integrals. Cosine x dx, I'm not going to use a substitution for, minus sine, whoops, did I, yeah, that's fine. Minus sine, 1, forgot to distribute. I'm like, where'd my cosine go? I can't have just sine 8x. That was no better than having cosine 8x. Without distributing, it's a problem. Cosine x sine 8x dx. And I didn't have this one all the way solved out when I looked at my notes. I don't know if this is a homework problem or not. Could be. So u is going to be equal to, be careful, don't make it the sine 8x, just make it the sine x. I don't have a problem having an exponent on something with, u to raise to a power is not a problem. But if I make the u sine 8x, I'm going to have a problem because I won't have its derivative. I do have the derivative of this, though. So du dx is going to be cosine x. So du is cosine x dx. So now I've got cosine x dx minus, and then this is just going to be, so the cosine dx part is going to be the du, and the sine is going to be the u. I'm just going to have u to the 8th du. And that's going to be no problem at all to integrate. You know what, I'm just going to finish this off, and if it's a homework problem, well, you benefit from watching the video. All right, so cosine x is just going to be negative, sine x. And let me rewrite that as f of x. F of x equals, this is just going to be sine x, right? Whose derivative is sine x? It's cosine x. For a second there, I was thinking of, when you take the derivative of cosine, I'm going to have a negative. I was forgetting the negative would not go on the, when I take the integral, just when I take the derivative. And then u to the 8th, that's just going to be minus u to the 9th divided by 9, right? And then I'm just going to put that down here. I didn't want to put the u's with my f of x. So f of x equals sine x minus, I'm going to replace that u with what it stands for, and it stands for a sine x, and it's a sine 9x, all over 9 plus c. And now we're done. See? Not too bad. Okay, so moral of the story was what I wrote over there on the right-hand side. Don't forget that. Okay? Pops up a lot in problems. This one's a simple one. I think you recognize it right away, that the u is going to be x to the 4th. Du dx is 4x cubed. Divide both sides by 4. 1/4 du is equal to x cubed dx. So 1/4 integral. And this is just going to be cosine u. Be careful. Don't make the u cosine x to the 4th, or you're not going to be able to do anything with that because you won't have its derivative. But we do have the derivative of x to the 4th. And integrating cosine u is not a problem. And then that would be du. So this is just going to be 1/4 sine u plus c, and replace. So f of x equals sine x to the 4th all over 4 plus c. And there we are. And you know, I'll check this one. I have a little bit of space. So if we check it, f prime of x equals, that's just 1/4. 1/4 sine blop, derivative of sine blop is cosine blop. I got to take the derivative of the blop. Derivative of x to the 4th is 4x cubed. Derivative of the c is 0. And the 4 and the 1/4 cancel. So f prime of x equals x cubed cosine x to the 4th. It's just what we see up there. See? It works. All right, so we got to be careful here what to make the u. Well, if I'm thinking, the derivative of tangent x is secant squared x. That's my u, that's my function. Don't put the 4 with it, just the tangent x. Now, if you make a mistake, sometimes I make mistakes, and you go, you go to take the derivative, and you go, I don't got the derivative. Just start over again. Just say, okay, I picked the wrong u. No big deal, right? Pick a new u, right? So, for instance, if let's just say I made a mistake. I put the 4 there. All right, so then du dx would be 4 blop, 4 tangent x cubed, or reduced by 1, and then the derivative of the blob, secant squared x, right? And then I have a problem there because I don't have all my blops, right? I mean, maybe I can pluck a tangent cubed out of it, but then that's a problem because then I don't have a tangent 4x. So you see that if this is going to be u, that's not enough to be du. So here I just showed you the wrong one because you may go the wrong way. And if you go the wrong way, just try a new way. So if we make u tangent x, then du is going to be secant squared x. And that's no problem. So a lot of times, don't leave the exponent there, okay? It's just going to be u raised to a power, and you'll use a power rule. No big deal. So this is going to be the integral of, so du is secant squared x dx. Need that. So everything is really covered here. I just have the u to the 4th du. That's just going to be u to the 5th divided by 5 plus c, and no problem, that is tangent 5x divided by 5 plus c. Right? And you can see that would go down by 1, and we'd have to take the derivative of tangent x. That's where the secant squared x came from. Right? And the 5 and the 1/5 would cancel. Right? And this one was a really easy one, I think. Right? So what to make the u? I can't make the u tangent ln x because I don't have a secant there. So obviously tangent wasn't part of u. But if u is natural log of x, du dx, the derivative of natural log of x is 1 over x, which means du is 1 over x dx. Everybody's accounted for, so except for the tangent. So the tangent stays, which is no problem. Well, it's sort of no problem. Tangent u du. Because guess what? We can't integrate tangent either, right? We can take the derivative of tangent, but we can't integrate tangent. But remember, on a previous video, and I'm not gonna just go back and say never we integrated it before by changing it, and this is what we got when we changed it. Nah, let's just change it, and then we'll integrate it one more time. So remember, tangent can be rewritten as sine over cosine. So sine u over cosine u du. But now I've got u's. I've got cosines and sines. That's a problem. We're going to do another substitution. So if you remember what we had done for tangent and what we got and how to integrate that, what that's going to end up being, it's okay to skip a few steps, but chances are you might not remember. But you can always just change it to sine over cosine and integrate that. I'm going to do one more u to u substitution with a v to v substitution. My v is going to be the denominator. It's going to be cosine u. The dv, this time it's respect to u. Derivative of cosine is negative sine. And you see, I got everybody covered except for that negative. Negative dv du is going to be sine u. So now I can integrate this thing. So now I'm just going to have 1 over v, negative 1 over v dv. And that's just going to be negative natural log of v plus c. I don't like that negative. Let's move it back. So I said move it up. Move it up using the power rule. Natural log v to the negative 1 power plus c. Right? So that's going to become 1 over v. And what was v? V was cosine. right? Not going back to the other one. I'm with V's now, not U's. So continuing on, we have natural log of 1 over cosine U plus C. I still have to now I've got to replace the cosine U, the U that's there, because we didn't start off with U's either. We started off with X's. What is 1 over cosine? Why, that's just secant. So let's replace that with secant, and meanwhile, let's replace that natural log of x, that U with a natural log of x. So, final answer. F of x equals natural log of absolute value of secant ln x plus c. And there we go. And we got to it. So it took us a little while. We did a couple substitutions. And if you remember, by the way, that the integral of tangent x has been derived to be secant x, or secant whatever happens to be taking the tangent of, then you can go from that one to that one. But remember, you can always derive that if you forget it, just like I did here. I think I'm going to stop this with this problem here, and I'm going to pick it up on the next one with this problem so this doesn't get too long. All right, so bye for now. See you in a moment.